Discriminant. The discriminant is used to find the number and type of solutions of a quadratic equation. The discriminant is a part of the quadratic formula. So if we think about the quadratic formula as x equals the opposite of b plus or minus the square root of b squared minus 4ac all over 2a, then the discriminant is the term underneath the radical. So the b squared minus 4ac, that is the value of the discriminant. Once you find that number, then you can tell the number and type of roots. So the discriminant will let you know what you're looking at. So if the discriminant is negative, so if the value under the radical is negative, well then we have two complex roots. Remember, it's plus or minus. And they're complex because if you have a negative under a square root, then you have an imaginary number. If the value underneath the square root is 0, then we only have one real root. And sometimes we call that a repeated root. And there's only one because if you think about it, the square root of 0 is 0, so that plus or minus kind of just goes away. If the discriminant is positive, then we have two real roots. They're going to be different numbers, again, because of that plus or minus in front of the radical. So let's look at some examples. So let's determine the number and types of solutions of the quadratic equation 9x squared minus 6x plus 2 equals 0. Well, the first thing we need to do is identify the coefficients. So we know that a is the coefficient in front of x squared. So a is 9, b is negative 6, and c is 2. Recall, the discriminant is b squared minus 4ac. So let's substitute our values in. So b is negative 6, so I have negative 6 squared minus 4. A is 9, c is 2. And we're going to simplify using the order of operations. So negative 6 squared gives us 36, and negative 4 times 9 times 2 gives me a negative 72. So 36 minus 72 is negative 36. Therefore, our discriminant is negative 36, so we will have two complex roots. They're complex because of that negative, and there's two of them, again, because it's negative. Let's do one more example. Determine the number and type of solutions of x squared plus 6x minus 12 equals 0. Again, we start by identifying the coefficients. A is 1, b is 6, and c is negative 12. We find our formula for the discriminant, again, b squared minus 4 times a times c. We substitute our values in, so 6 squared minus 4 times 1 times negative 12. Simplify using the order of operations. 6 squared is going to be 36, and then negative 4 times 1 times negative 12 gives me a positive 48. So 36 plus 48 gives me a positive 84. So since the discriminant is 84, we will have two real roots, and they will be distinct, again, because of the plus or minus piece.